Example 14 is a twist on example 13. So before we read it, I'm going to go back to example 13 and rehash that very briefly, and then we'll come back and read example 14 so you can see how the two questions differ. Okay, so back in example 13, you were trying to buy a car and you decided to save up for the car instead of taking out a loan. And we had to calculate the amount that you needed to deposit at the end of each month for 3 years into your savings account, which earned 4.5% interest compounded monthly in order to accumulate $18,000 needed to buy the car. Okay, so we went through the calculation and we figured out that this is the answer right here. Okay, that you needed to save $467.94 every month, put that into your savings account, and then your money would grow through those regular deposits and through the interest over a 3-year period, and you would accumulate $18,000 to go buy your car. Okay, what's happening in example 14, you will see is when we read through it, is that suppose this is out of your budget. Okay, you cannot swing saving $467.94 per month. Okay, you can only afford to save $200 a month. Okay, how long is it going to save you? How long is it going to take you to save the $18,000 for the car? Okay, and again, we'll keep everything else the same. We'll keep the same interest rate. Interest will still be compounded monthly deposits, all that will stay the same. Okay, so again, the question will now be if you can only save $200 a month, okay, how long is it going to take you to save up the $18,000? Okay, going into this question, we know it's going to take us longer than 3 years, okay, because if you could actually save $467.94 every month, then it would only take you 3 years to save up for the car. Okay, but if you can only save less than half of that, okay, it's going to take you longer than 3 years. Okay. All right, so let's go read example 14. Okay, again, it's piggybacking off of example 13. Suppose you can only save $200 each month. How long will it take to accumulate the $18,000 for the new car? By depositing $200 at the end of each month into a savings account, earning 4.5% interest compounded monthly. Okay. All right, so again, this is still an annuity. Okay, you are making regular deposits into your savings account. Okay, so again, saving money, regular deposits, no withdrawals. Okay, so you are going to be using the future value of an annuity formula. So let's write it down. Okay, so this time we are trying to figure out, we read the question, how long will it take? Okay, how long is it going to take to save up for the car? Okay, so we are solving for time here. Okay, this is our first instance of solving for time using the future value of an annuity formula. Okay, again, it's going to be complicated because the t is in the exponent. Okay, so it's going to be similar. We saw this with compound interest. Okay, it's going to be similar to doing that process. All right, so let's see. The interest rate hasn't changed. It's still 4.5%. Okay, M is still monthly, so it's 12. And our account balance, we still want to have an account balance of $18,000. Okay, and what's different here is we know the p-value. The p-value is the amount of each regular deposit. Okay, we will be putting in a deposit of $200 every month into our savings account. Okay, so that is your p-value. Okay, so let's go ahead and plug all of this in. Okay, and then we will solve it for time. Okay, all right, so let's set it up. Okay, let's see. I will start, I'm trying to figure out where I'm going to have the most room to do this. All right, these time problems take up a lot of room. Okay, so we got 18,000 is equal to 200 times 1 plus r over m raised to the m times t. We don't know t, so we'll just have to use the variable. Don't forget the minus 1. Okay, all over r over m. Okay, so that's how we're going to set this one up. Okay, right, so we are solving for time, okay? Very similar to doing this when we had the compound interest formula. T is trapped in the exponent or the power, okay? So the same kind of rules are going to apply here. You're going to want to identify what exactly is being raised to the power, to the exponent, and you want to isolate that guy. And then once it's isolated, you're going to take the natural log of both sides, okay? And then once you do that, you apply that property of logarithms where the natural log of something to a power is equal to the power times the natural log of the something, okay? So those rules, if you remember, I'm gonna have to flip back some pages here to figure out what page that was on. So let me look around really quick. So you can flip back to those notes if you needed to. I think this was back on page 7, okay, of this note packet where I wrote the rules for solving for time up at the top in case you need to refer back to that, okay? All right, so here we go. This formula is a little more complicated than the compound interest formula, so there's going to be a couple of extra steps you're going to have to involve here when you're solving for time, okay? First of all, we're going to identify what is being raised to the power, okay? Well, it's this quantity right here, okay? So the 1 plus 0.045 divided by 12, that's what's being raised to the 12t power, okay? You want to isolate this guy, okay? So you're going to have to get rid of the 200, the 0.045 divided by 12, the minus 1, okay? You're going to have to isolate this thing that I have boxed in red, okay? So this is how you get it by itself, okay? So the quantity in in brackets, it's like its own entity. All those things are together in brackets, okay? Well, what's excluded? The 200. The 200 is outside, okay? So the first thing we're going to do is divide both sides by 200, okay, to get rid of that 200. Okay, so I'm going to go to my calculator and we're going to enter in the 18,000 divided by 200, okay, and see what that gives us. Okay, so we're going to have 18,000 divided by 200, okay, that's going to give me 90, okay, so we are going to have 90 equals, okay, on the right, these guys will cancel, okay, and it's going to leave me with all the stuff that was in brackets, okay, so this, okay, and you can drop the brackets now, okay, because you've gotten rid of that 200, okay. All right, again, we are trying to isolate this, the thing with the exponent, okay? So what do you get rid of next, okay? Well, remember, what's on the right? The right is a fraction. You have top and bottom, okay? So what I'm going to do is get rid of the denominator, okay? This entire numerator is divided by 0.045 divided by 12, okay? To undo that, I'm going to multiply both sides by the denominator, okay? Because then if I have one in the top and then one in the bottom, they will cancel out, okay? Because anything divided by itself is 1, okay? So if you do anything to one side, you have to do it to the other. So let me make some room over here, okay? So we're going to have to multiply the left side by 0.045 divided by 12. Okay. All right. So again, what's going to happen is on the left, the right, you're going to have R over M in the top, R over M in the bottom. They will cancel. Okay. And then on the right, that's going to leave you with just the numerator. Okay, like this. All right, so that's the numerator, okay? On the right, or I keep mixing up my left and right here, sorry. On the left, I can go to the calculator and calculate this R over M times 90. Okay, so let's go do that, okay? So we're gonna have R over M times 90, okay? So 0.3375 will be on the left, okay? And then we're almost there. Again, we're trying to isolate this guy, okay? So this quantity, you're subtracting 1 from it. So the opposite of that is adding 1, okay? So if I add 1 to the right, I need to add 1 to the left, okay? So that is going to give us 1.3375 is equal to this quantity. Okay, so now we have isolated the guy that contains the exponent. Okay, all right, so remember your rules. Okay, this is the first step in solving for time. Isolate the quantity that is raised to the power. We did that. Okay, so now that you've done that, this is when you take the natural log of both sides. Okay, so you're going to take the natural log of the left. Whatever you do to one side, you have to do to the other. So now you need to take the natural log of the right side. Okay, natural log always goes on the left side. Don't forget that. Okay, and then what you're going to do is apply that property of logarithms we talked about. The right side is now the natural log of something to a power. So you can take the power and bring it down in front. Okay, so this is going to be in our next step. The natural log of 1.3375 is equal to the 12t, bring down the exponent, times the natural log of 1 plus 0.045 divided by 12. Okay, all right. I'm out of room, so I'm going to jump to an extra page to finish our work. Okay, so let me just rewrite this. So I'll put example 14 continued. Okay, so this is where we left off. We have natural log of 1.3375 is equal to 12t times the natural log of 1 plus 0.045 divided by 12. Okay, so here we go. Still solving for time, okay? And we've seen this when we solved compound interest for time, okay? The same rules apply. Instead of solving for t, you are going to solve for m times t, okay? So we need to solve this for m times t, which is 12t, okay? So the 12t is multiplied by this logarithm right here, okay? So we need to divide it off, okay? So we're going to divide both sides by this logarithm, okay? And then we will go to our calculator and divide these two logarithms, okay? On the right side, these two logarithms will cancel, okay? You'll be left with 12t on the right, okay? And then you've just got to, like I said, go to your calculator, divide these two logarithms, and that's going to give you a decimal, okay? So let's go put it in, okay? So we're going to have the natural log of 1.3375 divided by the natural log of 1 plus 0.045 divided by 12, okay? And there you go, okay? So remember, you are solving for time. This number that is coming out is a time value, not a dollars and cents amount, okay? So let's jot this down. Okay, so 12t is equal to this amount. All right, so once you get here and you divide the logarithms, remember what you do next. You always round time up when you're saving money, just to ensure enough time passes so that you can save the desired amount, okay? So we have 77 here is our whole number, okay? There's a 6 after, okay? Regardless of what number comes after, we're going to round it up to 78, okay? Even if this 6 had been a 1, okay, you would round this up to 78. You always want to round time up just to ensure enough time has passed, okay? All right, so once you do the rounding up, then you interpret your answer, okay? The 12 in front of the t indicates we are talking months, okay? So the amount of time it's going to take you to save the money is 78 months, okay? We can turn this into years and leftover months if you want, okay? But again, 78 months is a fine answer. You may leave it like that, but if you want to have a better interpretation of it, okay, we can take 78 months and divide by 12 months in a year, okay? That will give us, let's see, if we do that, that will give us 78 divided by 12. That will give us 6.5, okay? So let's see here. If we took, remember, okay, hang on, let me back up to make sure you've got this, okay? If you went back to where I was, okay, if you went back to the 78 equals 12t, and then we divided by 12 because there's 12 months in a year, okay, that's going to tell us that t is 6.5, okay? So when the 12 is in front of the t, that's indicating that this number is referring to months, okay? But once we've divided off the 12 and now we just have t equals, this is referring to years, okay? So 78 months is the same as 6.5 years, okay? So you can think of time that way, okay? You can also write this as 6 years, half a year, or 6 months, okay? So all three of these are acceptable ways of writing the answer. Like I said, if this time conversion confuses you, 78 months will do, okay? But remember, this answer makes sense, okay? If we can only save $200 a month, that's a lot less than the $467.94, I think it was, okay? You're saving less than half as much, okay? So it's going to take you more than 3 years, okay? It takes you over double the time, which is a sensible answer, okay? So saving up for the car, saving up that $18,000, if you can only save $200 a month with a 4.5% interest rate, it's going to take you 6.5 years to get your car.